Section 3 of this notebook deals with the derivative rules for undetermined functions. This is quite contrary to what we had been doing when the functions were explicitly determined algebraically. This time we are going to consider the opposite case, when the function expression is not there. How about this example? We know some function values and derivative values at specific x value, but otherwise we don't know what those functions are. Can we still find out the derivative evaluated at x equals to 2 when h is given by this 5f minus 4g? Yes, you can. You don't really have to know the derivative function. All you have to do is to use the derivative rule like this. H prime is 5f prime minus 4g prime, and then plug in x equals to 2. Now, do you know what f prime of 2 is? Do you know what g prime of 2 is? Yes, we do. They are here. Plug in those numbers and run your computation appropriately. You get your answer. Simple. What about you have a little bit more complicated case like this, f times g. In that case, you have to use the product rule. The first line is the product rule, and then plug in x equal to 2. Now, do you know all those f prime of 2, g of 2, f of 2, g prime of 2, and so on and so forth? Yes, we do. They're all here. Plug in all those numbers and then run your computation. How about quotient? The same. From the quotient rule, plug in those numbers and then run your computation. Slightly harder quotient, no problem there. Again, this is a quotient rule, denominator squared. And then how about the numerator? We have u prime v minus uv prime. Plug in the numbers, x equals to 2, and then run your computation. Finally, here's a problem that is a little bit worthy of our time. In that case, you'll have to use multiple rules because, let's see, clearly the quotient rule, but look at the numerator. We have a product there. In any case, this is a derivative computation. Denominator squared, so it's pretty conspicuous. And then this is u prime v minus uv prime. How about u prime v? This u prime requires a product rule. And then here, this is just straight ahead derivative for the denominator, and we are there. Plug in x equals to 2, we have appropriate expression. Now, are we ready to plug in the numbers? Numbers here. Yes, we do. Plug in all those numbers, and let's run your computation. In the end, this is what we get. I can give you a far more complicated case with multiple x expressions, maybe multiple derivative rules, but in any case, you can do these like this. Express them in terms of f and g, and then plug in x equal to 2, and then you can utilize these. Next problem. What if we have a table? Instead of those 4 values here, we need a lot more. In this case, we are using what? 12 values. Well, okay, let's do this. U is f of g of x, and let's find out u prime of 1. How do you find out u prime? Which rule do we have to use? Clearly, it's a chain rule. Step 1, the derivative of the outer function. Step 2, inside stays the same. And step 3, the derivative of the inside comes here like a dangling chain, the chain part. Plug in x equals to 1, and then do your computation. G of 1, look up the table. G of 1 is 2. So the G of 1 becomes 2 here. And then f prime of 2, f prime of 2, that's 5, so we have 5. G prime of 1, that's 6. So 5 times 6, that's equal to 30. We can do it like this. Let's go back here. When you take the derivative, outside first, outside in. Now when you're doing algebra, inside out. inside of the parenthesis first, and then look up the table. What if you have g of f of x? Pretty much the same. Chain rule, plug in x equals to 1, and do your algebra from inside out. Chain rule, outside in, algebra, inside out. The other problems are kind of similar. Just use the chain rule, plug in the values, do your algebra. Finally, let's go over to this kind of problems. When we have a graph, let's see, how about the first problem, p prime of 2. Let me keep it a bit closer. What is p prime of 2? P is this. So if you take the derivative, it's going to be the product rule. And then p prime of 2, well, here we go. Here's the answer key. The product rule, so far so good. And then plug in x equals to 2, we get that. But then again, here's the tricky part. What is f prime of 2? I don't have the table. I don't have explicit information. I have to go to the graph and figure out from there. What is f prime of 2? I have to look at the red graph because f is red. X equals 2 right here. At this point, I have to find out the slope of the tangent line. Clearly, this is horizontal slope. So we have 0. How about g of 2? X equals 2 is over here where my mouse is. And y coordinate is the function value. So g of 2 is the y coordinate value. And that happens to be 2. Here, look at this point, y coordinate. Now, f of 2, function value is the y coordinate, so this is 3. So from the red graph, when x equals to 2, right here, y coordinate value is 3. Finally, g prime of 2. Right here, we have to find out the slope. This is a line segment, so it's really easy. Rise over run is going to be positive 1/2. So there you go. Run your computation. You're going to get 3/2. How about a quotient rule? Q is f over g, and I want q prime of 7. So find out q prime of x using the quotient rule. And then you'll have to plug in x equal to 7. Here we go. Okay. Looks like I'll have to be satisfied with this much. I cannot put everything in the same viewing window. This is q. So upon taking the quotient rule, we get that expression. Plug in x equal to 7, we get that. Now, what is f prime of 7 in this quantity? At x equal to 7, here in the red graph, you have to find out the slope there. Derivative is a slope. What is it? Rise over run? It's 1/4. How about g of 7? Right here, and what's the function value? Function value is a y coordinate value. That's 1. So you get 1/4 times 1. How about f of 7 times g prime of 7? Function value here, the y coordinate, times g prime of 7. Here, the slope of this line segment. That's how you get 5 times negative 2/3. You can run your computation, but I think it's a waste of time. You can do it with your calculator. So let's just move on. This time, a chain rule. U is f of g of x. If you take the derivative you get the chain rule, the derivative of the outer function, inside stay the same, and then the chain part. In short, we have something like this. Let's see, let's try to put it in the same viewing window here. F prime of g of x times g prime of x. Chain rule. And then when you do your computation, plug in x equals to 2. And this is no longer calculus, it's algebra now, because you took the derivative here in the previous step. In algebra, the rule is inside out. Inside of parentheses first. What is g of 2? Here, at x equal to 2, blue graph, what's the y coordinate here? That's 2. How about f prime of 2 here? This point, red graph, and what is f prime? It's horizontal tangent line here, so the slope is 0, so we get 0. How about g prime of 2? Right over here, and that slope is 1/2, but it didn't really matter. 0 times whatever is 0, so we have it. Chain rule, that's outside in, and then plug in the numbers, we have inside out, and furthermore, we can find out the function value and the slope from the graph. Function value is y coordinate, slope is the derivative. How about the next problem? Well, okay, we'll try to do this. Let's see. Phi prime of x is equal to the derivative of the outer function, so g prime of f of x times f prime of x. This is what we get from the chain rule. And we want g prime of 1, so okay, g prime of f of 1, because we are replacing x by 1, times f prime of 1. Okay, can we do this computation? We should be able to. As far as our computation order is concerned, inside out, we took the derivative in first step. So calculus part is done. Now algebra, inside out. So g prime of, what is f of 1 here? Okay, here's my point in the graph when x equals to 1. That's why coordinate is 4. And then f prime of 1, this value over here, what's the slope here? It's a little bit difficult to tell. It looks a bit like negative 1 point something. Let's tentatively write it at f prime of 1. And then let's consider g prime of 4 at x equals to 4 right here. And what do you see? What's the slope there? Slope is undefined. To the left we have 1/2, so that's the left hand side derivative. To the right hand side, what do we get? We get negative 2/3. Two different values, two different limits. The limit does not exist. So this is basically undefined value times something. Overall, it has to be undefined. We have a cusp here, so we have to have undefined value. Here's the answer key, by the way. Okay.